Today we are gonna prove monotone convergence theorem, which is called MCT. It states that if we have an increasing sequence of non-negative measurable function, then we can exchange the limits in integration. So let Fn be an increasing, this word is important, increasing sequence of non-negative measurable functions such that Fn approaches to F, okay, pointwise almost everywhere on set E, then f d mu is actually limit n approaches to infinity f n d mu. So what is almost everywhere? Almost everywhere is nothing. So what is almost everywhere? So a set E belong to sigma algebra is said to be almost everywhere if measure of x difference E is 0. But forget about, forget about, like, don't worry about this much, okay? So now to prove this theorem, what we're gonna do, we're gonna actually use again Fatou's lemma. So Fatou's lemma says that we have a sequence of non-negative measurable function, then lim inf integral is less than or equal to lim inf integral. So since Fn is non-negative measurable function, thus by Fatou's lemma, f d mu is less than or equal to limit inf and approaches to infinity f n d mu. Now since f n converges to f, so fn is less than f for all n belong to n, and fn d mu is less than or equal to f d mu, integral order property, and then we can have lim sup fn d mu is less than f d mu, okay, and f d mu was actually less than or equal to limit infimum fn d mu. So what we have from here, lim sup fn d mu is less than or equal to lim inf fn d mu, but we always have that lim inf fn d mu is less than or equal to lim sup fn d mu. Thus lim n approaches to infinity inf fn d mu is actually lim n approaches to infinity sup fn d mu. Now if lim inf is equal to lim sup, this means the integral exists. Hence what we have, limit n approaches to infinity fn d mu is equal to f d mu, and we are done. See, we just use Fatou's lemma. And now if we have any decreasing sequence, then MCT may not be true. So MCT need not hold for decreasing sequence of functions. Okay, so we can give a counter example. So let fn of x is actually 1 if x is greater than or equal to n, 0 if x is less than n. So that is, we can write in the form of characteristic equation that n to infinity. Now what do you think? So clearly, so if you wanna draw, okay, so suppose, so my f1 is actually 1 if x is greater than or equal to 1, 0 if x is less than 1. So suppose if this is my 1 and this is my 1, so this means that my over here my f value gives me 1 and over here it gives me 0. Now what do you think about f2? So f2 is actually 1 if x is greater than or equal to 2 if x is less than 2. So suppose if this is my 2, so now over here my value is 2 but over here it is 0. So clearly f1 is greater than or equal to f2 is greater than or equal to f3 up to so on. So it is a decreasing sequence. And what is the limit? Limit n approaches to infinity, fn of x is clearly 0. You can prove it. But if you see limit n approaches to infinity, fn d mu, okay, this does not exist since limit n approaches to infinity, fn d mu, okay, so definitely n to infinity is actually infinity minus infinity. Okay, so we saw that in case of decreasing sequence, MCT doesn't work. So that was the example.